Hi. We're Robolicious from Springbrook High School, also known as Springbrook Team 1. Our advisor is Mr. Pratt.
So, I'm Abhinav Jambalingam,
I'm Xavier Costa. We're the structural designers of our NXT robot.
and we made a new robot with an NXT kit. This is our
I'm Tiknam. I'm the team manager. I was in charge of scheduling meetings, time management, and also offering moral support to my team.
I'm Nicholas Myers, and I was the main programmer. I used Robot C to program the entire robot.
So the robot itself was actually programmed in Robot C, as Nick had said. The main criteria that we used when we built it is we used 2 light sensors and 1 color sensor.
So the robot has to read the color sensor, react to it, and then it has to perform the task we say. So here's an example of a robot reading the blue line, parking it, and then it'll go out and then goes to the red line. So it has to stop in the red line and then exit out. So that's what happens with entering the city and exiting the city with the red line. That was a little demonstration.
And now we have the programming part. Some of our main programming ideas was that we used Robot C to program the robot, which is a third-party program. And instead, we did not use the Lego Mindstorm because it's a graphical way, and it was more for basic users. Some of the pros of Robot C is that it is text-based, and it is easy to use, as in you just type in a command, and it will make the motor move or search for a sensor. It gave us new opportunities because the graphical one, it didn't give us as many variations or variables, so we couldn't set a specific speed or do anything specific with the graphical one. Some of the cons about it was that there was very little language support for it, as in it was kind of a new language, it was third party, and it was a new language for us, so we had to learn how to use it.
And it gave little error support. If there's a syntax error, it basically doesn't give it, or we had to figure it out ourselves. And
this is an example of our code. This is the park method that we use. First, we had to understand Robot C, understand how it works, what methods you have to call. It was basically learning an entire new language. And then we had to learn the criteria and constraints, which were what do we have to do to get the robot to go around. And to do that, we made it modular, which was, we call a specific method, which is to move to the red line, to turn left, turn right, park, etc.
so we're going to talk about the design of the robot now. The robot was used Lego pieces and built out of the Lego kit. As you see, there's no pieces out of the kit, all are found in the kit. And the robot is made so it's balanced and proportional, so if you cut it in half, it gives the same thing. And it's sturdy, so if it hits something, it won't break. And it's flexible, so that you can move pieces around. Because of the Lego piece, you can just change pieces and add pieces in an easier fashion.
So the exact specifications, as I mentioned before, we have 1 color sensor, 2 light sensors, 3 wheels, 3 motors, and 1 brick. So we actually did specifically 3 wheels because we found in past competitions that 3 wheels is easier for turning and such.
So as you see, this is our skeleton of a robot without the brick on it. And here's the top view. As you see, there's the 2 wheels, and when you cut it in half, it's perfectly proportional. And here's the front view. As you see, the brick lays here. It's a side view. And this is a 360 view of a robot. You want to see. It's testing.
So the testing we did on the testing board, and also with difficult testing, we had to constantly edit the code to match the testing that we were always doing in the exact time that we had.
These are the sample boards that we had in school. We bought a big, some square foot board that covers basically half the room. And we have many possibilities for testing. And here's some testing cases. Here's the robot parking, so reversing to park. Here's the robot after park getting out and coming out. And here's the robot reading the red line, so it stops red line. And development stages.
So now we're going to talk about the development and the work group. So the first thing we did was I split our project into multiple sections or phases so that we could manage such a large project. First step was we worked as our whole club instead of just the 2 separate teams we have in our school, and just coming up with general ideas of what might be good to tackle the problem. Then we broke up into specific groups and thought about what our groups or what our teams would specifically want to go with. And so we researched general ideas and looked at the criteria and constraints of the competitions. And then finally, we set on a certain number of possibilities that we wanted to go with. And developed the proposals for those ideas. Here are some of what we wanted to, here are some of the possible ideas that we're going to go with, and Xavier will explain more of them.
So first idea was to do an upgraded air intake system because it allows for better mechanical push to the engine of the NXT brick. The next step was also to do a spoiler. As you can see on this race car, the spoiler is that big wing on the back. Gives a better push to the ground so the NXT can actually slide off the road. We actually want to do a hydraulic / off-roader suspension because we noticed some parts of the floor mat are actually a little more rough. Those edges, in case we go off, we'll always come right back. We want to do a turbo system because we noticed some straightaways on the mat. Save time, extra points. Just go all the way down the road.
Save time.
Dual exhaust system because, as everyone knows, dual exhaust sounds cooler, gives maybe 10-15 more horsepower, and it just in general makes us a better robot. We also want to do titanium drivetrain, just to ensure the mechanical issues, with the power of the turbo and the spoiler and the upgraded air intake, you never know what could go wrong, so we wanted to have the highest quality material. And also we want to do wings, because it gives that style, and everyone will recognize us from
Give a
even
best in
distance.
show
Yeah.
kind of thing. So, but it was a dream, unfortunately.
Eventually we realized that these features would probably get us disqualified for being too overqualified for the competition. So we decided to settle for these simpler ideas. So we went with 3 wheels, basically. We thought that was the most efficient way to keep the robot balanced and proportional, while also making the most efficient use of our resources. We also used a front-wheel drive system, because we thought that this would be better for a more stable turn, instead of having a rear-wheel drive. We also went with a scorpion design because we thought that that worked with the way our wheels were positioned, and also that would be the best way to aesthetically present our robot. Lastly, we decided to go with non-direct steering, which meant that instead of turning both the wheels at the same time, we only turned one of the wheels while we were turning.
This way it came.
That was also due to stability. Here's some things that we learned about teamwork. So for our group, our team worked hard as a whole, and we had to, because we separated the work into 2 parts, the programming and design. A lot of what we did in terms of the teamwork and the management side was making sure that both the teams or both the sides of the team communicate with each other and are constantly know what's going on the other side. So if we changed one of the sensors, then we would let the programmers know, and the programmers would change their code accordingly. Here's some improvements that we learned and then we also made throughout. First, we wanted to work more efficiently. Our team started off with a lot more members than you saw here, but not all those members were contributing equally to the group. And so throughout the process, we had to decide who was really contributing and who was kind of just there or who was distracting, and deciding how can we make the work that our team does actually more efficient. Finally, we also needed to make the program simpler, just because in addition to the programmers understanding it, we also had to make sure our builders understood it, and we had to communicate between the whole group. And so making the programming simpler would make it so that all members of the group can understand. Finally, we wanted to build a better robot. There are certain features of the robot which we'll explain later on that were not suitable once we actually complete the competition that we realized. Here's some things we learned. First thing we learned was group dynamics. And basically, that was that we had lots of different teams and lots of different people on our team. So we realized that we had to work together really hard as a group and that everybody had to collaborate in a good manner without fighting with each other. Second thing we learned was time management. That was basically making sure that everybody got all the things they were supposed to do done on time. The third thing we learned was teamwork. That's basically realizing that everybody has to contribute to the group, and all the people behind me are going to support me no matter what, and they're never going to leave me. Alright, Asia will talk about some of the more building-specific things we learned.
We're going to make the modular physical robot in the sense that it has to.
It has to basically fit the criteria, but also be very simple, so that there wouldn't be any extreme issues. If anything went wrong, say one piece was missing or such, we can easily change that. If any pieces need to be swapped out for a different distance, for example, when we were calibrating, we decided to do some changes on the sensor dimensions. It's very simple because it wasn't like a deep bracket where we had to take apart 3 different objects before we can actually get to it.
The robot has to be more compact because the programmer gives a different constraint and we give a different constraint to the programmer. So we figure that a more compact robot will give a better feel in the programming and a building side. And when we test it in the map, making little more condensed and compact will fit the road size and move perfectly instead of making wider and longer based because of the tails.
Some of the programming things that we learned as well was we had to make our code easier to understand, adding more comments, because after I wrote it, they were trying to figure out how it all worked, and it didn't work well with the team. Also, we had to set more values as variables, which means that when you're changing the motor speed, you set the speed for that specific motor at that specific time, but you can create a variable that you can just call that variable and it will change it all the time. We did that some of the time, but we think we should do it more. It would make it easier to change the code in a quick fix.
So to end our presentation, we'll leave you with a joke.
Or a riddle.
So why did the robot cross the road? Because we
Programmed it so.
Thank you.
Thank you very much. Thank you for listening.
We're Robolicious.
Thank you for spending time with us. And take care. Have a great day.